Today's topic is it's a theory by Bardeen-Cooper-Shrieffer theory. This theory, this is in short known as BCS theory. This theory will be used for the explanation of the topic. Today's topic is why superconductors defy resistance. That means why superconductors are having zero resistance. Okay. So, subject is what? It is superconductivity. And regarding this topic, one video was posted a few days back. You can find that video in the same channel. So today I am going to discuss that thing, means regarding the topic using BCS theory. You know that superconductivity was discovered by Kamerlingh-Onnes in 1911. And thereafter, the first microscopic theory which came into existence and for which the scientists, that means three scientists are there, John Bardeen, then Leon Cooper and John Robert Shrieffer. And after their names, according to their names, the name of the theory was given to be Bardeen-Cooper-Shrieffer theory, or in short BCS theory. They submitted their paper, means they submitted their theory in the year 1957, and for their contribution they were awarded Nobel Prize in Physics in the year 1972. Okay, so this is the first microscopic theory of superconductivity. So, microscopic theory, that means knowledge of quantum mechanics is required to understand this theory. So first, and you know that superconductivity, this phenomenon occurs at low temperatures. Low means what? Low means it is near to this temperature 0 Kelvin. That means minus 273.15 degrees Celsius. Minus 273.15 degrees Celsius. This is the lowest possible temperature, and near to this temperature the phenomenon of superconductivity occurs. This is known to you, I think. Okay. And you have also heard, I think, you have also heard that high temperature conductivity or superconductors, high temperature superconductors, yes, research is still going on. Still, few of the scientists have got success in this field, high temperature superconductors. What is the aim of this research? High temperature superconductors. Aim of this research is that superconductivity, this is required to develop many technologies. Okay, I am not going to discuss those technologies here in this video. I will make a separate video to discuss all those things. And so maintaining so low temperature, nearly 0 Kelvin, is very difficult and very expensive. So if you can do the same thing, means if you can achieve the property of superconductivity at sufficiently higher temperature, then in that case that will be better for us, for the scientists or for the companies or for the technologists. In that case, that will not be so much highly expensive, and difficulties will be somewhat reduced. Okay, but here high temperature does not mean room temperature. Here high temperature is the temperature at around 77 Kelvin. 77 Kelvin, this is the boiling point of nitrogen, liquid nitrogen. Okay, this is the boiling point of liquid nitrogen, and the boiling point of liquid nitrogen is 77 Kelvin, and near to this temperature, the development of certain materials such as ceramics means few scientists have got success to make superconductors using ceramics at this temperature, and this is called high temperature superconductors. Still research is going on. This is not fully developed technology. Anyway, my aim of this video is to discuss BCS theory to explain superconductivity. So I have noted down here total of 5 points. First point is formation of Cooper pairs. Okay, formation of Cooper pairs at sufficiently low temperature. These Cooper pairs forms. Cooper pair means this is the pairs of electrons. At sufficiently low temperature, electrons interact with lattice vibrations. Lattice vibrations is also known as phonons. So at sufficiently low temperature, electrons interact with lattice vibrations and form Cooper pairs. Cooper, this was invented by the scientist Robert Cooper, and according to his name, this name is given Cooper pair. Okay, so Cooper pairs are formed at sufficiently low temperature. Okay, and next point is energy gap and quantum coherence. Energy gap means this Cooper pairs occurs near the Fermi energy level. Okay, so a minimum amount of energy is required to break those electrons apart. Okay, a minimum is, there is a certain energy which is called here the minimum energy, below which it will only be possible. So that minimum energy is required to break apart the electrons in a Cooper pair. That energy is called here energy gap. Okay, and one more term is here used, that is quantum coherence. Here quantum coherence means after the formation of Cooper pairs, if there are so many Cooper pairs in a lattice or in the given conductor about which we are talking about, okay, so in that case quantum coherence forms. Okay, it is a state, it is a quantum state which is called here quantum coherence. Next comes collective quantum state. Collective quantum state means collective. This term is used when there are so many Cooper pairs. So after the formation of Cooper pairs, they due to the lattice vibrations, there you will find some decrease in the density of electrons. And somewhere in some region there you will get decrease in the density of electrons, and in some regions you will get increase in the density of electrons. So when there is decrease in the density of electrons, there what happens, more number of Cooper pairs are formed, and collectively those Cooper pairs reach to a quantum state. That quantum state is called here collective quantum state. So the next point is zero scattering and resistance. Zero scattering and resistance. After the formation of those collective quantum state, okay, those Cooper pairs in a collective form, they can move through the lattice without scattering or dissipating energy. And this results in zero resistance, and for which in that case the material will be known as superconductor. Okay, because resistance occurs due to the collisions of electrons with the impurities or the lattice defects. That is the reason behind the resistance in electrical conductors. I mean normal electrical conductors. Okay. So that is the reason behind electrical resistance. So if you can avoid those collisions of electrons with the impurities or the crystal defects, in that case there will be zero resistance. And if resistance becomes zero, then that material will be converted into a superconductor. Okay. And last point is macroscopic quantum phenomena. This is not related with superconductivity, though I have noted down this point here. This is macroscopic quantum phenomena. Means macroscopic level, one phenomenon can be observed when a material reaches to a state of superconductor. Okay, if superconductivity is achieved, in that case the macroscopic phenomena which can be observed is known as Meissner effect. Meissner effect means it is expulsion of magnetic flux from the interior of the superconductors. Okay, that thing will be discussed. I will discuss that thing in a separate video, not in this video. Okay, I never want to make lengthy videos, long videos. Okay, because most of the viewers, I know most of the viewers don't like to watch long videos. Okay, so short videos, I think. And one more thing is that it is not the video on entertainment. Okay, if you can you can watch a movie for 2 hours long, for 3 hours long movie, because when you are entertained, in that case it is very easy for most of the viewers to watch that easily. Okay, because you are entertained in watching those things. But when you are learning something, and when your brain work is much, okay, when you are learning complicated theory, in those cases what happens, if I make long duration videos, in that case most of the people or most of the students can't wait so long, or better to say, they will lose their patience in watching difficult things at a stretch for so long. So that's why I always try to make videos shorter in length with respect to time. Okay, anyway, so these were the 5 points which is known as Bardeen-Cooper-Shrieffer theory, or in short BCS theory. And here the main point, which is the key aspect of the BCS theory, is the point number 2, that is energy gap and quantum coherence. So in the discussion of energy gap, I have used one word that is called Fermi energy, Fermi, Fermi energy. Okay, anyway, all these things will be discussed in separate videos. For Fermi energy, I will make one video. Fermi energy in the field of superconductivity. What is the role of Fermi energy in the field of superconductivity? Like that. Okay. Then I will make another video. What is the role of Cooper pairs in the theory of superconductivity, etc. like that. Okay. So here, my target was to make only the analysis of this BCS theory. So 3 things are there. First, formation of Cooper pairs. Next come this collective condensation of the Cooper pairs to form quantum coherence. And then what is required, that is the quantum coherence, right? Quantum coherence required. So 3 steps are there. First, point number 1, then point number 3, then point number 2. Okay. So these 3 things are required to achieve superconductivity. Anyway, and I would like to request you one more thing, that whatever your requirement, if you are watching my video with an interest, then please write in the comment box. Okay, write in the comment box. Your comments are valuable for me and for our group. In my group, there are two more persons you know. Their name will appear in the video. Ms. Shreya Mondal and Ms. Shonita Ghati. Both of them are there, but they are behind the camera. In front of the camera, I am present to deliver this lecture, but their contributions should be acknowledged by me. I should always thank both of them for their contribution in making such videos. Anyway, thank you. Thank you for, this is the end of this video. Thank you. Thank you for watching this video.